And now we are proceeding to our first and very interesting session on Ukraine's energy trends. I want to welcome to the stage Oksana Aliieva, who will moderate this discussion. Oksana is from European Climate Foundation. I pass the floor to you. Please present your colleagues who will be speaking and have a good panel.
Thank you so much, Anastasia. It's my pleasure to be here. So first of all, very big thank you goes to the European Ukrainian Energy Agency with the support from the German government for hosting us here and providing this space and platform for discussion and for potential cooperation. So my name is Oksana Aliieva. I'm Senior Associate in the European Climate Foundation. And here I have this privilege to moderate the panel with distinguished guests. But firstly, let me briefly introduce myself. So I've been working in the sector of energy climate for decarbonization of the energy sector of Ukraine for the last 14 years. And why I'm moderating the first panel, which will be mostly, and you will see it, about the looking into the potential scenarios and technology needs for development of energy sector in Ukraine. This is because one of my guilty pleasures is to work with the energy sector modeling. So in different occasions, I was working a lot with stakeholders, and we have supported a number of different types of modeling of development of energy sector in Ukraine. One of them was back in 2017-18, and it was actually the first modeling of the whole Ukrainian economy and how it can transfer until 2050 towards 100% renewable energy. And that time it, we believe, gave this tremendous shift towards the discussion from, okay, it will not fly, it's not possible, from it's possible, it's complicated, let's think about how to do that. So it was really first attempt to look into the technical and economic feasibility of Ukraine to have its economy relying on 100% renewables. But since that time, many things have changed. So here we will today try to answer questions which we believe are interest for the audience here, among whom are many investors. And if you're here in this room, we believe that you are interested in investing into Ukraine, but those questions we have on the table, like, okay, which technologies, what is the bankability of different types of projects, what Ukraine needs in terms of its perspective, how energy mix should and could look like in coming years. So these questions that we will try to address today with the distinguished panelists we have, and here at this moment I invite you to the stage. So Olena Konstantynova, analyst at Strategic Planning and Risk Management Department of Ukrenergo. Please, the round of applause. Balint Silhavy, principal at Boston Consulting Group. Elleanor Robbins, principal investment officer, Europe-Ukraine lead at International Finance Corporation of the World Bank Group. Dr. Georg Zachmann, co-founder of Green Deal Ukraine. Igor Petryk, market development director in Europe of Wärtsilä Energy. And Theresa Gebhardt, Caspian and Black Sea Program Officer at International Energy Agency. So very well welcome. Thank you so much for being here with us. Yeah, thank you so much. So let's not make it long. I know, and we heard a lot from participants that actually many of them waiting specifically for the presentation from you. Olena, we know that with the martial law, the informational flow and access to data for many stakeholders working in the sector is limited. And many of them rely specifically on data from Ukrenergo. So we look forward for your presentation, and I believe that Ukrainian transmission system operator Ukrenergo does not require additional introduction. we really acknowledge the outstanding work you're doing. So yeah, the floor is yours. We look forward to hear how you believe the Ukrainian sector should look like and which technologies you believe it should rely on. Please go ahead.
Okay. Good morning. I'm very pleased to be part of such an important event today. And in my presentation, I would like to speak about current and future landscape of energy sector of Ukraine, its needs, its plans, challenges, and investment opportunities. So let's start. And speaking about our plans, I should emphasize that Ukrainian energy sector, it's now strategic goal of Ukraine that energy sector must be as close as possible to climate neutrality by 2050, and the other key national targets are presented at this slide. Among them, there is not less than 29% of renewables by 2030 in electricity generation mix. And someone can argue that nowadays it's a very, it's a little bit big, it's a little bit ambitious goals for a country who is in the state of full-scale war already for 4 years. And indeed, Ukrainian energy sector faces severe challenges due to Russian military aggression. And at this slide, we present the estimation of Ukrenergo. This slide says that total available capacity of our integrated power system lost from the beginning of the war accounted around 54% as of the end of the October. It's available capacity, it's not installed, it's a maximum theoretical level of the capacity that can be used in the system. You can see that the most affected capacities are thermal power plants, combined heat and power plants, also wind power plants, as the most of them were situated on the south regions of Ukraine, and they are partially occupied now. Also, we lost a part of hydropower potential because of the destruction of Kakhovka power plant and the repeated attacks on the other facilities. And also, there is a reduction in nuclear power potential because of the occupation of Zaporizhzhia nuclear plant. We also suffered a big drop in consumption level. Maximum consumption per hour in autumn-winter period fell by about 30% comparing to the pre-war level. And also a part of the named challenges. We also have more historical challenges in our energy system, which connected with the follows. First of all, over 50% of critical infrastructure capacities is outdated. And also Ukraine historically highly relies on the centralized and coal-fired generation, and historically there will be a lack of fast ramping reserves, and it leads to the insufficient flexibility in our power system. Also, our power system needs expansion of cross-border transmission capacity. But despite all the challenges, there is good news about renewables in Ukraine. And during the period from 2022 to 2025, the additional 1.3 gigawatt of new green capacities were commissioned in Ukraine, and its share, together with large hydro, in the mix, in the energy mix of Ukraine, keeps be higher than it was in pre-war days. So in 2024 it reached about 20%, split evenly between solar, wind and large hydro. As we are moving to the forecasts, Ukrenergo expects that our demand for electricity will rise by 2034, at least by 15%. And this growth is driven by expected economic recovery, by expected further electrification of economy and fulfillment of our energy efficiency targets. So maybe that is the main question of this panel: what will our power system look like in 10 years? And this slide presents the vision of Ukrenergo on this question, and it based on the adequacy report by Ukrenergo. There are some missing numbers, but they are connected with the restrictions of our situation. This slide gives us the vision of our energy system in future, and this system will be moving to decentralized and carbon-free generating resources. We are focusing on wind, solar, hydro, and nuclear still, but they will be balanced by maneuvering capacities like thermal power plants and combined heat and power plants, including using biofuels. And also it must be balanced by energy storages as well. So maybe this slide I will skip. According to Ukrenergo estimates, also already by 2030 we need to build additional capacities. They are presented on this slide, and you see that gas-fired power plants, there are some missing information. Okay, I'll say it aloud. Gas-fired power plants, we need about 1.4 additional gigawatt of new facilities. Thermal power plants plus 0.4 gigawatts. Energy storages, our needs is about 1.4 gigawatts, or 2 gigawatts, sorry. And wind power plants plus 3.4 gigawatts, and solar plus 3.1. And the expected investments needs are around 8 billion euro. So what does our country need to do to boost such development of new generation facilities. These measures depends depends from the type and the purpose of the facility, and in fact Ukraine has already introduced a number of mechanisms to stimulate the construction of generation capacities, new generation capacities. For example, for increasing flexibility of the energy system, Ukrenergo held a number of special auctions for ancillary services, and I can illustrate that our needs in frequency containment reserves were covered by 100%, and our needs in automatic frequency restoration reserves are covered by around 70%, and decisions about the next auctions will be made based on the monitoring of the implementation of the relevant projects by the winners of previous competitors. So for the construction of renewable generation, we can say that investors can rely for possibility of obtaining a fixed, for example, a fixed preferential price for natural gas, and for fees for providing ancillary services per fixed price. Also, there are such mechanisms that boost development of renewables. They are feed-in tariff, feed-in premium, auctions for support quotas allocation. Also, there is a self-production or net billing, corporate power purchase agreements, guarantees of origin. So we are expanding this list. Also, speaking about incentives, I want to say that Ukrenergo has developed, and the regulator has adopted a number of amendments to the legislation that aimed to further improving the procedure for connecting to electricity grid. And first of all, there is a capacity reservation mechanism. It allows investors in wind power plants to carry out project development for an additional 2 years without the risk of losing the approved technical conditions for the grid connections. We also have a cable pooling, ensuring the possibility of connection and join most efficient use of the network of existing power producers. Also, there is a possibility to install generating units beyond the contracted capacity, taking into account BESS. Some procedures for hybrid combined power plants have been also improved, and there was mandatory advance payment for grid connection has been introduced, and it allows for to reduce the queue for the connection to the grid, and to reveal from dormant applicants. So maybe I will finish my presentation with the next steps that we need to to implement, to take, to assure further development, sustainable development of our energy sector. First of all, it's financial stabilization. There is a need to solve the problem of debts in electricity market. First of all, on balancing market. Also, we need fully implementation of EU legislation. We need to eliminate constraints, internal constraints in our transmission system, and also develop our interconnections. And also some stimulating of economic activity and consumption, electricity consumption measures need, and as well as localization and specific educational programs for this sector also needed. So let me finish with that, and I thank you for attention, and
thank you so much, Olena. Thank you. I believe
pass
it
the
was
floor to the next.
And I saw people were making pictures of your slide, and especially of the table with the capacities until 2030 necessary, so it was extremely helpful. And here, coming to you, Balint, so in BCG you also have your tools for modeling, so we are curious to see how your perspective outlook based on modeling of the energy sector of Ukraine look like, and how does it coincide with that what Ukrenergo says? So over to you.
Yes, thank you, Olena. And first of all, it's gonna be hard topping that numbers because, like, you know all the numbers from first hand. So let me start with taking a step back on, like, where are we starting from. So we as BCG last year worked together with the Ministry of Infrastructure and Reconstruction on, like, a broader economic vision for Ukraine. So what the economy by 2040 could look like, and what are the steps that is needed to get us there. So here is just a brief view. Like, we looked at all the sectors, all the historical advantages, natural resources, everything that Ukraine has. What could be the leading sectors of the economy in the next 15, 20 years? You see there are the usual suspects on the top of the chart, and energy is also there. Energy is unique because energy requires a lot of investments in itself as a sector, and it's a growth vector for Ukraine, but it is also an enabler for any other economic activity in the country. So this is the view that we started from. And then, when we have a view on what the economy should look like, or would be great to look like, what is the energy sector that is required to get us there, to support this vision? This is where we started from. If we take a historical view, Ukraine was one of the most energy-intensive economies in Europe, and it was not even close. There were a lot of improvements, but still there were no structural changes in the energy sector over the last 30 years. So where does this lead us to? We all know that there was a massive drop in demand when the full-scale invasion started. But based on the economic vision, we don't expect the overall energy consumption to grow above the 21 levels until 2040. But what you see here is that how that energy is going to, what type of energy is going to be used, it's massively shifting. So the share of electricity is going to be nearly doubling in the energy mix. So the power sector is not only need to reconstruct, but we'll need to focus on actually covering for a double of consumption. Olena had, like, probably better numbers on this, but we also tried our best. So there were, like, at least a 60% drop by the war impact in the available generation capacity. So that kind of lays the groundwork where we are starting from for a prospective rebuild. And the other consideration that I'm pretty sure everyone is aware of is the energy trilemma. You always have to balance between energy security, affordability, and sustainability. Fortunately, renewables can cover all three dimensions, but in themselves, they are super hard to cover a full energy system. So the question comes, how to really build out a stable, resilient, affordable energy system for the future. Just one thing about the technologies. There are a wide range of technologies that we can invest in and that we can put in place. And usually how we compare the cost of the different technologies is based on LCOE. And you can see, these are numbers for Ukraine. There is gonna be generally an improvement in LCOE for all technologies. And the renewables are gonna be the most competitive. Also, the existing nuclear is also very competitive. So that gives us kind of an advantage in also to not only ensure sustainability, but also assure affordability. And the third thing on the security, that the renewables are decentralized. And a decentralized energy system, or a more decentralized energy system, is going to be more resilient than the current one. So that leads us to, okay, how should it look like in the future? We developed a couple of scenarios. This is our base scenario. Well, this is linked to the 2040 energy vision. On the left-hand side, you can see the capacities that we expect to be built up. You can see there is a massive push in solar and wind, as most of the people in this room really believes in. But we also believe there is going to be an expansion on nuclear capacity, and there is going to be an expansion in gas-fired capacity. But if you look at the right-hand side, on the generation mix, gas, the share of gas in the actual power generated is going to be shrinking. So the role of gas, besides the massive build-out that is expected, is going to be more towards balancing the market. You will see the largest generation is going to be coming from renewables and with a nuclear backbone. And that is going to be one of the key strengths of Ukraine. It was also in the past, and this is expected to also be in the future. A large nuclear backbone, this is now something that most of the countries are aiming for. If you look at the different plans of nuclear new builds, everyone is trying to build base load nuclear so that it can balance the renewables. And this is gonna be a huge advantage going forward. How much would it cost? I have much higher numbers than Olena, but like the time frame is also very different. So now we are taking a look until 2050, because some of these technologies, like nuclear, needs 15 to 20 years to build out. So it doesn't really make sense to start with a 5-year view. But if you take a look, most of the investment into the energy sector is going to be needed in the power sector. A lot of new generation capacities, a lot of refurbishment, and also a lot of investments into the grid. And that is something, if you look on the right-hand side, the grid investments are actually going to be second only to the new nuclear investments that we expected. This is something that we always have to keep in mind. It's great to build out the generation capacities. We need the grid investments to be aligned so the system can operate efficiently, and the system will actually enable connecting the new renewables. And yeah, that was me. So thank you, everyone.
Thank you very much. Indeed, the message that we take out of that from both presentations from Olena and from you is that demand is going to grow. And this is a good signal for investors that, like, anyways, in upcoming 5, 10, 15 years, considering your different time perspective and your modeling, but anyways, considering sector coupling and decarbonization of another sectors of economy, not just like of the power sector, we will need a lot of new capacities. So it's good to know that there is market developing, growing, and for investors, there is a big space, and those who come first would actually benefit. So this is the message that I believe we all will take out from today's session. But you, Balint, also mentioned decentralized renewables development, and in your Olena's presentation, it was that in 2022, 2025, basically the biggest share of new capacities that have been installed in Ukraine was decentralized. And this is again another signal to look into what is already bankable and cost efficient. And here I come to you, Theresa. So we know that International Energy Agency recently has published a report about empowering Ukraine through decentralized electricity system. We, together with our partners in Strat and Clean Energy Lab, also have looked into the medallion of how many decentralized renewables Ukrainian power system could absorb. Like our estimate was around 5-7 gigawatt would be optimal, but it's very interesting to look into your outlook and to your perspective. So how do you believe this balance between utility scale and decentralized generation could be optimized for Ukraine? So please, over to you.
Thank you very much. Can someone share my... Perfect, thank you so much. So I'm building up a little bit on what Balint just said, and also Ukrenergo, and shedding a little bit light from the IEA's modeling perspective. So as we just heard, Ukraine is facing the fourth winter of the full-scale invasion and has lost the majority of its power generation capacity. Rebuilding this generation capacity is extremely important, but it matters how we rebuild it just as much as how fast we're doing it. Because simply recreating the old centralized system, of course, would rebuild the same vulnerabilities for Ukraine. And so Ukraine has to redesign its system around distributed energy resources, short DERs, which with a strong focus on renewables and storage. So to explore how those resources can help the Ukrainian power system, the IEA developed a model in Plexus as part of our distributed energy resources roadmap that you just mentioned. Our model incorporates both a capacity expansion and a production cost component, which I'll touch upon in a second. And this model enables us to look how the system could evolve as it becomes more decentralized, but also how it would need to operate in the future. So looking a little bit more midterm, so 2030, based on our one of our scenarios, which includes that not all CHPs and CHPs can be recovered, that Zaporizhzhia cannot be recovered, but that nuclear is going to be extended otherwise. We anticipate that in addition to today's capacity, Ukraine would need 24 gigawatt of solar, 11 gigawatt of wind, and 6 gigawatt of energy storage to meet its climate and energy targets as written down in the NECP. But which path should we choose to get to this 2030 vision? Because as you can see, it's very ambitious. So it depends all about the context, because on-site DERs such as rooftop solar, batteries or small gas turbines, they can be deployed in weeks and months compared to the conventional power plants. And as their name says, they can be deployed in close proximity to demand. On the other hand, utility scale DERs, so large scale solar parks, wind parks, and grid scale storage, they deliver the volume and cost efficiency that we need for long-term decarbonization, also en route to Ukraine's EU integration and also its industrial recovery. So while different DERs, they differ in terms of their deployment speed and of course, since we're facing the winter, also the wintertime production capacity, they nevertheless remove many vulnerabilities faced by conventional power plants, as they often do not have a single point of failure. They're closer to demand. They provide the very much needed flexibility, which Ukraine is currently lacking because they lost a lot of their flexible capacity because of the attacks and/or occupation. And of course also because they're way more difficult to target for the Russians. Therefore, those two approaches, on-site and utility scale, they should not be seen as competitors. They are actually complementing each other. And we're already seeing this taking off in Ukraine. Because based on the IEA's recent renewables report, and also I just saw it in your presentation, there was more than 1 gigawatt of solar added to Ukrainian grids in 2025 alone, and the majority of this was distributed. And simultaneously, also utility scale projects as the DTEC battery storage project that also Deputy Minister Andarak was mentioning are going online hand in hand with plans for expansions and new projects regarding wind. However, I also have to address the elephant in the room, which is that DRs require, of course, significant upfront costs. And in our model, we also had a look on this. So as you can see on the graph, rebuilding Ukraine's power system for its immediate needs, just based on small modular gas turbines, would require upfront investment of around 13 billion USD. And as more diverse the deployment of DERs would be in the energy mix, as more expensive would be also upfront investment between 15.5 billion USD and 23 billion USD. However, what is very important also to highlight here is that a more diverse set of resources is also more effective over the lifetime of those assets. Because this would lead to around 5.5% savings across total costs, so the most diverse mix, mostly due to the savings on fossil fuel costs. And this is obviously very important also in times of scarce gas supply and the ongoing attacks on the gas infrastructure. And beyond this, of course, the mix also benefits energy security and the building back better logic, as it represents a system which is less reliant on fossil fuels and more sustainable. So I told you now that DRs offer great benefits for the system, but of course they present also challenges to the planning, operation and supervision of the power system due to their more modular nature and their location both on the consumer side and the utility side of the meter. And therefore, in our distributed energy roadmap, we developed a comprehensive set of recommendations, and which I will now touch upon briefly. The first one is really bridging the immediate gaps while building towards a decentralized energy future. So we saw already great progress being made, but it's really important that Ukraine continues to work on a holistic DER strategy backed by detailed regulatory and legislative proposals. Then, hand in hand, number two, really ensuring maximum value to the grid. So this is a team project. The regulators, system operators, and market operators must ensure market design rules that enable both renewables and battery to maximize their value across multiple applications. So this means flexibility and islanding in the system, for example, not just self-consumption, to deal with local congestion. And being here in Germany today, I'm sure that some German colleagues will be telling you one thing or another about this. Then also, of course, reserve peak capacity, etc. And this goes hand in hand also with that more revenue stacking options are then now available to de-risk investments, but increased revenue is just one part of it. Others would be clear power purchase agreements, predictable permitting, and grid access so that large solar and wind projects remain bankable. And last, but definitely not least, is of course aligning finance and regulation, because blending public, donor and private funds can help to reduce the high cost of capital in Ukraine's energy sector. And we see this, that stakeholders who are interested in investing now and in the future in the Ukrainian energy system, this is often one of their biggest hurdle when talking with them. And I'm really interested on what IFIs and some other colleagues will tell about this today. Yes, so in summary, with analysis like this, the International Energy Agency contributes to support Ukraine and its partners en route to a more sustainable, diverse, flexible, and resilient power system. So please feel free to have a look on this report, which my presentation was based on. You can find it on the internet in IEA. It's also available in Ukrainian, FYI. And for the colleagues here who are particularly interested in on-site and solar PV, we just also finished a techno-economic analysis of 3 distinct policy options, discussing how enhanced rooftop solar deployment in Ukraine can take place. This report will be launched in a couple of weeks, so stay tuned for this, and thank you.
Thank you so much. And while you are back in to your seat, Theresa, one very brief follow-up question, and it will also then refer to you, Olena. So how many gigawatts of distributed generation can Ukrainian system absorb in its current state? Because we also heard about the project Ray of Hope from the Deputy Minister Anderak, and we know that this sector is the sector that is developing currently. So what is the limit, and is it there at all? So do we still have capacity to push for development of this segment?
I think there is.
It should be online.
Oh, yeah. Okay. I think that we have for a little, not a little, but a potential for further development of distributed generation resources. But we also need to have our system ready for this, for absorption, this generation, this type of generation, and it also take a time. So we need to find a balance to solve this problem.
Yeah, I just can second what Olena said and also what Balint said in terms of the grid expansion, and obviously that we should not forget also to invest in the grid and make the grid ready so it can really absorb all the renewable and decentralized generation we would put online. This goes hand in hand, and we know that Ukraine is not the only country who is struggling obviously with this symbiosis, and particularly obviously in times of war, but it's very important that we're obviously not forgetting the grid aspect in this whole discussion.
Perfect, thank you so much. And I promise that we will keep you entertained and we will have time for questions and answers. We are on the way there. We have also another presentation based on Plexus, and I invite Igor Petryk from Wärtsilä. We know that in the past you also collaborated with Ukrenergo, and that you also have your modeling given, and you even had the possibility to look into the sector coupling, specifically with the heat sector. So yeah, over to you. What is your vision of those technologies Ukraine needs now?
Thank you, Elena. And also apologies to my fellow panelists for leaving you in this tough moment. I was willing to make pictures to take with me. Good morning or afternoon, where we are now, morning still. I will be talking about power system of the future, but not as far as 2050. But still, I will try to sort of draw the line between today and where we are going. And definitely the power systems will be decarbonized, renewable, no doubt. The question is when, and the question is how we move there. What is the optimal path? And this is the topic of my presentation. We in Wärtsilä have been doing the system modeling around the world, and we have already done studies in more than 200 power systems and countries globally. Probably we are the most advanced or experienced Plexus modeler in that respect. This modeling actually helps us to see different scenarios. We are not predicting the future, definitely. Nobody can predict. But we can see what are the boundaries, what is the potential channels that we can go, depending on the decisions that we are making today. And I will show you a very simplified example. This is based on Germany conditions, but very simplified just to show you the logic. If you want to decarbonize a power system that is today 100% fossil-based, thermal, and for example, its peak demand is 100 megawatt. Can be 100 gigawatt, doesn't matter. This is just to show you a principle. And then we want to get it fully decarbonized over time, in 2045, 2030, whenever. So basically, where we will reach the crossroad is when we need to decide, do we want to go straight to renewables, or we allow our modeling software to accept fossil fuel, and make it like in 2 steps. We have, as I said, we have analyzed so many different systems, and we have done this so many times, so that in this simplified example, if we choose to go to no fossil fuel, and we just jump to renewables, as the title or the topic of our conference is saying, renewables and storage, no wonder, all the politicians are happy to talk about that. And maybe this audience is also happy because the association is very much focused on renewables. So I respect that. Renewables will be driving the development. But with this approach, to cover 100 megawatt of peak demand, you would need to build 750 megawatt of wind, and 3.8 gigawatt hours of storage. And then you are fine. Definitely, the system is overbuilt, and its LCOE is way too higher than the original system that we departed from. If we allow the software to select between different fossil fuel technologies, but still target to maximize the decarbonization, Plexos selects gas, no coal, definitely, no nuclear, no biofuel, sorry. But it's a cost optimized, I forgot to tell you. It's a cost optimized modeling. So for that reason, if we have the target to decarbonize at the lowest cost, Plexos selects wind, no wonder for Germany, battery storage in much lower capacities than in this straightforward scenario. Plus some gas, flexible gas. In this case, it's not gas turbines because they are not flexible. It's reciprocating engines. And the LCOE is more than 2 times lower than in the target scenario, or the first scenario, also lower than initial starting point. But you would say, yeah, but you still have gas. Fine. How much? 24%. So gas is playing only the balancing role. So it's filling the gaps. And the majority, I mean, this is formula, around 80% decarbonization with existing technology is no wonder. I mean, no, it's nothing new. Everybody knows this already for a long time, that this is approximately the level that you can reach with existing technologies at reasonable cost. So what is required further? You just need to wait until power to gas or other decarbonized fuels are available, and then you use the same existing technology. So you use the same wind, the same storage, maybe you build a bit more solar, and you add a little bit capacity to generate to feed the electrolyzers, and you produce hydrogen or derivatives, and then you run the same gas capacity. The investment is not sunk cost. It can be utilized further in 20, 30 years. So this is the cost. Yeah, sorry, forgot to say. And then the final LCOE is, in this example, 82 against 145 in the total in renewable only scenario. So the picture says for itself. It's simplified. Of course, it doesn't take into account many complications and constraints, but as I said, we have done this many times, and the process of decarbonization is always optimal in this way. In Ukraine, we have done also a few fundamental modeling exercises. Starting in 2018, we defined the amount of flexibility that is needed to unlock renewables. And then we also looked at the path to decarbonize system later on. And in 21, we also suggested to the Ministry of Energy coal plants decommissioning scenarios. And then finally, just before the invasion in January, we presented to the Minister of Energy the district heating optimization scenarios. And district heating is something interesting because it has its very important role. We are saying district heating is the largest source of flexibility for the power system. And this statement is not only my own statement. Many countries in Europe, they have adopted this already. And we have seen this in Denmark, in Germany, being implemented as we speak, in Poland, in Czech Republic. It's becoming like a common knowledge. But not this plant, Darniska. No, sorry. It's not going to work. Instead, our modeling, also in those countries that I mentioned, like in Poland, we've done 5 different studies in these different cities. The result is the same. Replacement of coal-fired boilers is done by a combination of different technologies. Electric boilers, heat pumps, heat storage, some gas boiler for peak. And those technologies can be used to convert renewable power to heat. By doing that, renewables can avoid curtailment. And this is what typically is said sector coupling. But it's not the whole story. The whole story is that when there is little renewables in the system, you need to add more power. And then
Igor, you approach in 10 minutes.
Combined heat and power capacity, I'm finishing. Combined heat and power can also produce electricity and heat. And so this is the full cycle sector coupling, and it's the cost optimal combination. And then I will not show you this slide. It means this is the way how we modeled the co-optimization of heat and power in Ukraine, where we demonstrated that the same principle that I just showed you on the previous slide. And this, from this modeling for 2030, using the Ukrenergo assumptions, we just ended up with the optimal power system. And it consists of district heating technologies, renewables, and all the rest which we just assumed being the same as in Ukrenergo scenarios. Same wind, solar, nuclear, biomass, and pumps, hydrant heat and pump storage. Compared to the Ukrenergo base case scenario, if we use district heating for balancing, there are huge benefits. Lower total system cost, 40% less emissions, less curtailment, more nuclear used. Yeah, and then I'm finishing this. I still have an answer to the question later on. What are the constraints to implement this? But I would say, so far we have seen a lot of this technology, containerized solutions being delivered. They are very, very helpful, but they will not save the situation. You need to have more robust 30+ years lifetime technologies or capacities that can run not only just for 60,000 hours, running hours. And we can talk about this later. Thank you.
Thank you so much, Igor. And this was simply another proof of how we can't consider the power sector in isolation. And I'm happy that you could join us back on the stage. We've done with the presentations, but we still have a lot of questions to address. And Elleanor, I recall we were sitting at the EU-EA Day in 2022 back in Vienna, discussing the security, political challenges, and the investment climate in Ukraine, risk, and how all of that hinder development of renewables. But we are now in 2025. Many challenges remain the same, but some of those we understand better how to address. So from your perspective in IFC, how you approach selecting projects to support, and what is your current portfolio in Ukraine? What you have on your table?
Great, thanks Oksana, and thanks for having me. I don't need a clicker. I'm a double outlier here because I don't have a presentation and I'm a banker, so I'm definitely an outlier on this panel, but you've done a very nice job of reconnecting this together, because ultimately, and it's been super interesting to listen and see these presentations on the sector modeling, which incidentally is what I was initially hired in the World Bank Group to do. So that's where I started out my career, but haven't done it for a very long time. And I've been schooled today, and it's been really nice to see this. What we know, I guess, and what's clear, there are differences in the numbers here, right, and the technology mix, which are very interesting. What's clear is it's going to require quite a lot of money. And what's clear as well is that money won't come from public sources, shouldn't really come from public sources, because of course the sovereign will remain constrained, and donor funding should be used sparingly, should be used in a very targeted way, and wherever possible should be used to unlock private capital. So that's where many of the people in the room come in, and that's where I hope also IFC can come in. For those who don't know us, so IFC is the private sector arm of the World Bank Group. With the largest global development finance institution. We have been indeed very heavily re-engaging in Ukraine over the past 3 years. I'm a more recent newcomer than many of you to Ukraine. I've worked in many different geographies, but I have been focusing 100% of my time on our program for infrastructure and energy in Ukraine over the past 2.5 years. And it is nice to see some of the progress since indeed that EEA Day in Vienna a few years ago. So overall total program in Ukraine now over the past 2.5 years, we've mobilized $2.7 billion, so that's a significant amount. Within that, energy has been a critical kind of focus area and will continue to be going forward. Previously, we were not present in the sector, so had looked very closely at the green tariff framework and decided not to participate. There were concerns there around simply, the sustainability, overall financial sustainability of the sector, and how the payment flows would be able to be made based on the level of tariffs. But of course, since 2022, we've wanted to heavily re-engage. And do see a lot of opportunity as well in the energy sector. So it's been an area of focus, of course, due to the needs, but also the opportunities there, and the recognition that the private sector is already playing a very important role, and again, will need to do so going forward. In terms of technology, we have also been quite focused on the renewable energy side. I would say there, there's clear business case for many technologies. Obviously, climate considerations, decentralized nature of some of the assets, good domestic resource, and the fact that brings energy security. Not wanting to rely on too many imports for gas, which unfortunately we're seeing now again. The difficulties of in the upcoming winter, but I would also concur with what Igor was saying in terms of, gas most likely has to be part of the story, and the World Bank Group is also, looking at financing gas projects as part of this transition as well. And you may have seen there's recently been an announcement on the World Bank Group re-engaging in nuclear. So who knows? Maybe we can play a part across the full chain. What are some of the models that we've seen work? So over the past couple of years, what we've been doing, two big kind of, I would say, ways that we've been engaging. One has been more on the kind of through indirect financing models. And so that's been a program, we've put together a program of risk share facilities with Ukrainian banks. And the idea of this was really to allow Ukrainian banks to do more in terms of lending to, I would say, medium-sized corporates. So we've been talking about distributed generation. Many corporates were coming to us with requests for loans for, 1, 2, 5, 10 million euros, which we're quite resource constrained, and we're not able to process those individually, simply speaking. So we've partnered up with 4 different banks. We've signed now facilities with Raiffeisen, with Crédit Agricole, the Ukrenergo Bank, and with OTP Leasing. that also allow the bank to do more in terms of lending. So these are for on lending of 1 to 10 million euros. And we built in there a small capex subsidy as well when the use of proceeds is renewable, so for clean energy uses. So a lot of that's been around rooftop solar and storage. So that program's now approaching, that's now a $400 million equivalent program. The other way that we've been investing has really been through direct investments, so to large-scale projects, not only in the energy sector, but in the energy sector, we've have been primarily focusing on wind. It's been mentioned as well, but there are obviously, for those who has been part of previous discussions around this, there are big benefits to wind in terms of the quality of the resource, in terms of the nature of the assets, in terms of the generation profile that matches very well the demand profile in Ukraine. So that's been an area of focus for direct investments. We announced together with colleagues from BSTDB and EBRD who are here too, and with the support from the European Commission and other partners, the investment in Oko Group's first wind farm earlier this year, and now moving to the second one. And then we're also processing about 550 megawatts of additional projects to that first one that was closed. So, I hope by the next time, certainly by the next time we have this event, we'll be talking around 750, 800 megawatts of wind power financed, which starts to get the momentum to move the needle. In terms of models, it's what we're seeing is a mix. So corporate finance models, hybrid models, where I would say, project finance but with some more heavy corporate reliance than we would see in other markets, where the project finance markets are more, or the project finance models are more attainable. And now we are also starting to see solid project finance models, mostly with corporate PPA offtake that's been mentioned here. But I think we will and should move over time to seeing also project finance done on a merchant basis. Maybe just very briefly in terms of bankability criteria, as this question was also asked, I would say there are the kind of Ukraine-specific aspects, right, which of course all investors are taking into consideration in different ways. For us, what that's meant in practice is looking more closely at location, obviously taking a differentiated view. Ukraine's a vast country, I think. In the outside world, or people who are not familiarizing themselves with the market, there can be this kind of blanket, oh no, it's Ukraine. So, which I think is unfortunate, because there are so many good locations and good projects and thriving economies within Ukraine that location does become a factor. Asset type, it's been raised, is also a factor. Looking at distributed generation, distributed assets is where we've so far been focusing. Again, with the idea to take on more risk and move over time. And then, of course, the availability of de-risking instruments. And I know there'll be a session dedicated to this later on, but everything we've done, we've also been able to do thanks to donor partners. So we've raised over 900 million now of blended finance sources from donors, and that's been absolutely instrumental in terms of us being able to take more risk and to leverage private capital. And then the other factors, I would say, are not specific at all to Ukraine. It's really the fundamentals of, does the project make sense? Can the cash flows be repaid? How? Pretty fundamental. What's the business model? What's the business case? Who's driving the project? Have they done it before? It seems a bit basic, but it's kind of it kind of is in the first screening. Are they? What are the capabilities to take this forward, including on technical aspects, including on environmental and social aspects? And then the third bucket of criteria is really more around, what's the impact from a climate perspective, from an inclusion perspective, what's the role that we can also play as a DFI? Are we needed? There are cases where we're not needed, and I'm happy to not be involved, right? So it's trying to fill a gap in the market. Otherwise, we don't need to be there. Those are the main ones.
Thank you so much, Elleanor. I believe it was very insightful, and considering your current portfolio. Considering your current portfolio that you mentioned, I believe we can also conclude about those types of projects that, as you said, make sense. And here what is also important beyond finance and beyond technological understanding what is required in Ukraine on asset perspective, I believe it is also necessary to understand which changes are coming. We also heard from Roman and Darag that there is a bulk of legislation coming. We know that the amendments to the law on auction are coming. RED 3 directive is under implementation now. And another dimension to that is overall EU integration, but also integration with EU markets and electricity market, energy market. So what does it mean for current projects, and what does it mean for those who just consider to start the operation in Ukraine? And here, Georg, I come to you. We know that in Green Deal Ukraine, you look closely into this sector. So what we in this room should know from this perspective while making a decision on what type of investment to make in Ukraine?
Yeah, thanks a lot, Oksana, and many thanks for the invitation to this event. First of all, I found the panel super fascinating, especially with the 4 different. Is it working? Yeah, okay. With the 4 different modeling runs and seeing how different results can come up. And I think I will not show our modeling results, but it would be fascinating to compare also a bit what drives the differences in the outcomes that have been quite stark. I would like to follow up a bit also what Elleanor said, that private investments are going to be crucial in Ukraine if these massive investment plans are going to go ahead, and that framework conditions are crucial for this. And for getting private investments, it's all clear we need stability and level of price predictions. And for that, I would argue that EU integration is essentially the big kind of stabilizing anchor for the Ukrainian market, both on the regulatory side, but also in terms of the price developments. And let me explain a bit. So the current situation, as we perceive it, is that cross-border electricity flows between Ukraine and the European Union are happening. There is quite substantial lines. Our understanding is that the current commercially available capacities are significantly smaller than what would physically be possible to use. So here, a massive increase could still be in the cards, and additional increases can be done also by increasing the technical capacity. And the second issue that I see currently is that that we see a lot of electricity flowing against the price direction, not really predictable, so that the market for cross-border trade is not really working. So as an investor in Ukraine, you cannot really be sure whether you succeed in the auctions for the capacity, how much will be auctioned. So the big prize will be to get market coupling. And I, as everybody before, would like to look at 2030. And for 2030, I see 2 scenarios. It's kind of the edge scenarios, but it's kind of really scenarios that are kind of together, they are the most likely scenarios, either one or the other. One scenario is a scenario where Ukraine does not become part of the European market. And it will be worse than today, because Europe is introducing the carbon border adjustment mechanism, and the carbon border adjustment mechanism should start next year. And this carbon border adjustment mechanism would force everybody that wants to sell electricity from Ukraine to the European Union to pay 75 euros per megawatt hour to the European taxpayer. That will kill almost all trade from Ukraine to the European Union. We calculated in this super nice report that Ruven is one of the co-authors. You can also catch him probably over coffee here. We calculated that electricity trade will go down by maybe 60% between Ukraine and the European Union. Ukraine will see much more transit flows, because then electricity will be traded from Poland through to Romania, but Ukraine will be essentially largely cut out if CBAM is implemented without any remedial action. That's the bad scenario, which would mean Ukraine being isolated. The good scenario for 2030 would be the market coupling scenario. The market coupling scenario would be great for investors. They would have stability in having access to the European market because they would bid in the Ukrainian market, and the electricity prices would automatically align with the European electricity prices, and they would have a liquid market with competition and much more predictability of the market. The price caps in Ukraine would have to be abolished in order to make that work, which also gives more predictability. And for renewables investors, it's a good news. This market coupling only goes hand in hand with the introduction of carbon prices in Ukraine. And carbon prices would make renewables significantly more profitable in the market. That is, for me, the two scenarios: ETS and market coupling in 2030, or no carbon pricing, or maybe carbon pricing, but no market coupling and a very, very isolated market. Now, there's a process until 2030, and the temporary fixes are available. So Ukraine can now try to push in Brussels, and I also see people from the European Commission here, to essentially get some force majeure or derogations from the CBAM rules. So it might, for 2-3 more years, use the current mechanism, but that will be, at some moment, it will be over, because this is only going to be granted if Ukraine has a credible pathway to a carbon price. Otherwise, CBAM will kick in and market coupling will be dead. Now, what needs to be done for market coupling? On the one hand, so we still, and Deputy Minister Anderak spoke about that, we still have the draft law in the Parliament. It's delayed. It's delayed for a year now. Because it is delayed, the market operator cannot be designated. Because the market operator cannot be designated, Acer does not accept the application of Ukraine, and only when the application of Ukraine is accepted, the 18 months period starts. So we are kind of already now in a time when market coupling cannot start in 2027, but likely only in 2028, and that's if everything goes right now. So Ukraine should really move here. It's part of the Ukraine facility, and I think everybody that wants Ukrainian private investments in the electricity sector to flourish should help to push the European Commission, but especially the Ukrainian side, to move ahead here. Last sentence, one challenge that we see is that in the current draft law, there is still discussions on having 2 auctions for the Ukrainian electricity market. One, essentially, that is only for the domestic market, and a few minutes, I think 30 minutes later, there will be the auction for the cross-border trade. We are highly skeptical of such an approach, because it essentially reduces liquidity, invites gaming, because you might have one market with a price cap and one market without a price cap. Some smart people will figure out how to short-circuit this system and make money out of that, but it's not really how a market, in our view, should work. And with that, I stop. Thank you.
Thank you so much, Georg. I believe there should be questions in the audience, and we have a bit of time for them, so we can select few. Victoria will help us with the mic, so please keep your hands lifted. So I see one hand on the right. Please introduce yourself.
Hello, Alexander Kruk, Samalab, EPC contractor. As a former banker, I would like to thank you for the presentation and the fascinating panelist audience. I have 2 questions, actually. What are your expectations regarding the certificates of origin in Ukrainian origin, actually, to be traded in Europe? This would may potentially resolve 2 issues: the liquidity problems of the green energy producers in Ukraine, and second, bring the certificates price in Europe lower a bit, which would positively probably affect the inflation. And the second question is, do you expect any regulation to be imposed on the energy management systems in Europe and Ukraine as a mitigant for Chinese technology and equipment which has less alternatives nowadays? This is it. Thank you.
Thank you so much. I'm not sure whom to address that. I'm not really convinced that there are people who are in the position to address here on the stage. I believe you would like to address this question yourself. Or, so one.
It's a banking story, practically.
So with certificates of origin, so Elleanor, if you would like to address the possibility of recognition of Ukrainian certificates of origin in Europe.
Yeah, I'm not sure. I'm not sure I share the view it's a banking question yet. Maybe it will become one at some point, but certainly from our perspective internally, we're not yet really viewing it or incorporating it indeed into the financial case, because there's not yet that track record, right? This is still a new development. As you say, there's no cross-border trade yet of guarantees of origin. So how this market will develop, yes, that I'm probably not the person to comment on it. I hope that it does further, and it's encouraging to see the steps that have been taken in that direction. But certainly from a banking case perspective, for now, there's not really, the monetization is not, in our base case, put it that way.
And considering the second question, I believe that later today in the course of the conference, there will be right people to address that. So you can repeat your question.
I can quickly reflect on that, and probably later on you will have like a much detailed answer. So when we were doing the economic vision, like we had this discussion and we talked to a lot of embassies over the globe, and everyone is thinking about investing in Ukraine. And just given the scale of investments at this stage, it's going to be really hard saying that, okay, there are specific nations or specific technologies that we are saying no to. There might be restrictions, a couple, but like fully cutting out Chinese technology, that is something that would need super hard commitment from everyone else. That, okay, if it's not the Chinese technology, everyone else is happy to invest in, I don't know, in telecommunications, into Nokia and Ericsson technologies. Until that is there, it's gonna be hard to expect Ukraine not to pursue the best possible solution.
Thank you so much, Balint. Any other questions? So we have one here, Victoria, we have one here in the first row.
Dennis, ETL Group company, EPC for renewables in Ukraine. I have a question to Olena Konstantynova. Lately, when getting the technical conditions for connection in Ukraine, we are required from Ukrenergo to make a calculation of electricity flows, generation flows, and some regions also require double connection points, which is twice more costly for anyone to connect. Will it be the new standards for all the regions, and why was it realized? So maybe there are any incentives on getting to the previous scheme of connections. Thank you.
I'm sorry, but maybe I cannot explain you the answer because it's a little more technical question, but I'm sure that you can repeat it me after in the break, and I address this question to specialists.
Planning department,
yes.
You might not deal with that directly, so that's. But maybe you can connect bilaterally, and Olena will help you to connect to the right people in Ukrenergo. To close this session, I have one provocative question to you. So imagine I'm a billionaire, and I'll pay you really, really well if you advise me what to invest now in Ukraine, and if the project is successful, you will be granted 100 million euro. So what two technologies you will advise me to invest today? If there are volunteer, you can start. If there is no one, I will appoint a person to reply the first. Yeah, everyone will answer. Like, it is the question who will go first.
Let's start.
Thank you, Olena.
I'll choose energy storages, And I would like at this time, I'll choose gas-fired renewable generation.
So let's come closer to me, Balint.
I'm gonna be the second opinion. So gas-fired generation, also cogeneration in that regard. So I think that's one, and the other is on the renewable side. There is ample room for new wind investments.
Yeah, if I can cheat and say renewables with co-located storage, maybe maybe it's
yeah,
I do,
that's,
and I
count.
also agree with gas being a key part of the equation as well. Yeah, and just I mean on this supply chain question, just because it came up, and I would just concur with what's been said. I think it's safe to say, I mean, there's no energy transition without storage, right? I mean, that's clear. It's not possible. And for now, there's no storage, that's only made in the EU. So I think it answers the question.
Yeah, so via subs is double renewables with co-located storage. Georg?
I mean, it's clear that the profitability in the end will depend on the regulatory framework. If you abstract from that and just look into what is most needed and if it would be paid well, I would give a strong preference to distribution grid investments. I think Ukraine needs significant investments in that area. Has been underinvested for a long time, and that helps everybody also to integrate their technologies better.
Great. Igor?
Let me split into two answers. One answer is from me. If it was my money, I would not invest. Sorry, I'm still maybe too conservative. If I'm working for a billionaire who can risk, this is another story. Then I would suggest again, as Olena said, energy storage, but longer term storage, and maybe we still need to wait a little bit. I'm sorry for the long answer. The part of the explanation is that the ancillary services battery storage application is already full, almost full.
Yeah, so we heard that.
Yeah, so that we need longer term storage, and it needs to go down in capex. And then another technology is gas-fired, flexible gas-fired.
Thank you, Theresa.
Yeah, I will not say something shockingly different, but I think it's really nice that we, despite having, different models, different approaches, that here in the end we come to similar conclusions. I would also second what Georg said regarding the grid distribution system and storage, but of course diversification is key.
Thank you so much. Please, round of applause for this wonderful panel. Thank you for all of our panelists. And I'm pretty sure that you can also follow up bilaterally with every panelist, and you have the answer, like go and invest. Thank you. And over to you, Anastasia.